So we talked about the ways to prove triangles are congruent. Now what we're going to do is we're going to use that in some theorems or to prove some things. And so we're going to do two examples here, and then you can work through the rest of your paper afterward. I did cut off something here, so this vertex over here is a D, which you have on your paper anyway. So you can follow along. For a lot of these, we're going to be filling in the reasons, the statements already given to us. So as a reminder, we know that triangles can be proved congruent using side, 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 angle, side, angle, side, angle, and angle, side, angle, angle, side. And so we'll be seeing at one of those in each of these theorems because, or in each of these proofs. So in this first one, you have the given information there, and so that obviously is going to go in our first step in our proof. And when we have information written in our proof, written in our statements, it's a good idea to go ahead and mark it right on your figure. So put the given down here. We are just trying to prove the triangles are congruent. And draw the information on the picture as you know it, and that's what I was mentioning. So AE is congruent to CB. So let's come up here, find AE, and we're going to mark that congruent to segment CB. So I'm going to put a little mark on each of those. Also, I'll just mention this here. These are not always drawn to scale. AB, that's right here, that is congruent to CD. So that's this one here. And B is the midpoint of ED. So this obviously this is the given, so we can write that in there. Now you obviously have the statements here on the left already written. It's not always going to be that way, so as you're working through a proof, the next thing you would do is you would look at what you know in your proof so far and look for any definitions that might be helpful. So here congruent, we know congruence, and sometimes we change that to equality, but we really don't need to when we're dealing with triangles because we want to show congruent sides. B is the midpoint. Well, that is a definition, and the definition of midpoint says a point splits the segment into two congruent parts, which means this part here would be congruent to this part here. And so that's what's written next. EB, segment EB, is congruent to segment DB, and that is definition of midpoint. And now we have what we need. We have three sides of one triangle are congruent to three sides of another triangle, so therefore these triangles are congruent, which we have that written here. AEB is congruent to CBD, and that we can say we know they're congruent by, and we can just write SSS. If you want to, you can write side, side, side. You can write the words out. So there's our first proof. Nice and simple, 3 steps. And we ended up using side, side, side in that one. Going to the next one. This one has a lot of information, but it will probably end up working out pretty nicely as we work our way along. We have a couple perpendicular statements. AB is perpendicular to BE. So all this stuff we're going to put right there in our first thing, and that's going to be given. And so I'll put given here, and then also I'm going to come up to the figure and start marking this stuff. So AB is perpendicular to BE. Perpendicular means right angle, which actually that's our next step there. So same thing here, DE is perpendicular to BE, so I can mark those two. I also know AC, that's this right here, is congruent to DC. And I also know angle BAC is congruent to angle EDC. Now, I know these are right angles because that is the definition of perpendicular. So I'm going to go ahead, that's really by, let me step back. Looking at this figure, now that we marked it, we probably see this is going to be an angle, angle, side, congruent to angle, angle, side. But we do need to state these are congruent, because it didn't state that angles were congruent, it stated that they're perpendicular. Perpendicular means they intersect to form right angles. So we know these are right angles because that's the definition of perpendicular. And then what is true about all right angles? Well, angle B is congruent to angle E. All right angles are congruent. And so since all right angles are congruent, we know those two specific right angles are congruent. This was supposed to be an apostrophe S. Angles are congruent. And now we see that these two triangles are congruent by angle, angle, side. It's two angles and a non-included side. And those are two proofs of how to prove, or proving triangles congruent. You can work on that next worksheet. I believe I wanted you to do 1 through 9 or something like that.